Given 30 meters of fencing for a rectangular garden, find the interval of possible length when the garden area must be greater than or equal to 50 meters. So we're going to have to remember some geometry formulas. First of all, for the entire amount of fencing, the 30 meters, we need to remember what the perimeter is, because a perimeter is the entire amount of fencing you need to go around the plot. Perimeter P is equal to 2 times the length plus 2 times the width. So for this problem, the perimeter is 30 equals 2 times the length plus 2 times the width. Let's solve this for W. We'll be able to use it in that form better. So move everything to the right and leave W on the left. We got W equals 15 minus the length. Now we're going to use that result in the next geometric formula, the formula for the area. The area in this problem has to be greater than 50 meters. So remember the formula for area, A equals length times width. Okay, so let's use the W width that we just developed. A equals L times parenthesis 15 minus L. Okay, let's go ahead and distribute multiplication by the L inside the parentheses. We get area A equals negative L squared plus 15L. I just rearranged the negative value in the front because I wanted the higher power of L to come before L to the first power. Okay, so we've got our model, and we want this area A to be greater than or equal to 0. Okay, so replace A with negative L squared plus 15L, bring down the greater than or equal to sign, and bring down the 50. That means the area has to be greater than or equal to 50 meters. All right, so let's. This is a second degree inequality, and we know the steps for solving this. Move everything over to the left side. The other side will be 0. Factor the non-zero side. Well, first I want to get rid of that negative sign in front of the L squared. It's really hard to factor when your highest term is negative. So let's multiply both sides of the inequality by a negative 1. Now that will make this an L squared minus 15L plus 50. But it's going to flip the direction of our inequality sign because we just multiplied both sides by a negative number. So we have less than or equal to the 0, which is 0 times negative 1 is 0. Now we can factor easily our left-hand side by guessing. L minus 10 times L minus 5. Bring down the less than or equal to, bring down the 0. Now let's solve the equation. Imagine this is an equal sign and we're solving an equation. It's equal to 0, and we got L minus 10 equals 0 gives us L equals 10, or union together that with L minus 5 equals 0 gives us L equals positive 5. Okay, there are 2 solutions for when we set this factored inequality equal to 0. Let's use these. They're both real numbers, no imaginary ones, so we can use both of them to partition a number line. Okay, so we're going to partition a number line at the smaller value 5, the larger value 10. Write the factors, and we're going to find out what the sign of each of the factors and their product is in each region. So choose a value for x smaller than 5. Plug that, not for x, but for L. Plug that value for L in and see what the sign is for each of your factors. Well, let's say since it has to be any number smaller than 5, it's probably easy to use 0. Let L equals 0. 0 minus 10 is negative 10. That's negative. 0 minus 5 is negative 5. That's negative. So we have a negative times a negative in the first region. All right, and you multiply that together, you get a positive. Now for the second region, choose a value between 5 and 10. I don't care. Choose 7. That's a number in between. Let L equal 7. 7 minus 10 is negative times 7 minus 5 is positive. So we get a negative times a positive equals a negative. And for the final region, let L be some number greater than 10. Let's say 100. Let L be 100. We get a positive for the first factor, a positive for the second. Multiplied together gives you a positive result. All right, so what did we need back in the earlier step? The product L minus 10 times L minus 5. It had to be less than or equal to 0. Remember that? Less than or equal. To be smaller than 0 means that you're negative. So only use the values of x in the middle region because those are the ones that gave us a negative result for the product. Okay, so we want our A value to be greater than or equal to 0. All right, so that meant that the original inequality had the equal portion in it. So include the endpoints. Go back up and put boxy brackets on our graph at 5 and 10. Now we write our solution, curly set bracket, all real values, L, such that 5 is less than or equal to L is less than or equal to 10, or boxy bracket 5 comma 10 boxy bracket, or boxy bracket shading between 5 and 10 with a boxy bracket. Okay, so in words, we really should answer this in words. The original question was find the interval of possible lengths L when the garden area is greater than or equal to 50 meters. And the answer is the interval of possible lengths is anything from 5, including 5, to 10, including 10.